Okay, so let's try this electro problem here. So as always, pause it here, try to do it on your own first. But what this question is doing is it gives us an oxidation reduction reaction between silver ion and zinc. And then, so the first part here is it's asking us about some stoichiometry. So it gives us grams of solid zinc, information about the solution of silver nitrate, and asks for our limiting reactant. Okay, and so let's start with that. In this stoichiometry problem, we can start with either the 1.5 grams of zinc or the other one, or the 250 mils of the 0.110 molar silver nitrate. Either one works, but let's start with the 1.5 grams of zinc. Okay, so we start with the 1.5 grams of zinc. We can figure out how many moles of zinc we have. So we know the molar mass of zinc is 65.4. So grams of zinc per every mole of zinc. Okay. Then based on our balanced equation here, so we know that for every 1 mole of zinc, we're going to need 2 moles of silver plus there, so silver nitrate, so we're going to have, it's a 1:2 ratio between that and the silver nitrate. Okay, and so we can do a couple things with that. If we figured out how many moles of that, we could also compare it to how many moles of silver nitrate we've given into the solution with the 250 mils of the 0.11 molar. Okay, so we have 1.5 divided by the 65.4 times 2, which comes out to 0.0459 moles of silver nitrate. So 0.0459 moles of silver nitrate can be used up by this 1.5 grams of zinc, but when we need to compare that amount to how much silver nitrate we actually have in there. So 0.25 liters times 0.110 molar to 0.055 molar zinc 2 plus. Okay, so that'll be the concentration that we have. Okay, and so the next part it asks for part B here. It's asking us to solve for the standard potential, so E, between this reaction. So we have two half reactions here, right? So we have the silver plus going to solid silver, so we need an electron there. Going to our solid silver, and then we also have solid zinc going to zinc 2 plus with a couple of electrons. Okay, so we don't really care about the balancing the amount of electrons right now, because with E that's not going to make a difference. But we need to take a look at our table of reduction potentials. One of them is going to be switched around. So in this case, the silver ion is the one that's going to be reduced. So silver ion is going to be the one that's reduced. So if we look over here, our reduction potential for silver is 0.8. And then the reduction potential for zinc is going to be negative 0.76, but we have to switch that around because it's being oxidized in this case, so it's going to be positive 0.76, and then the sum of these is going to be 1.56. Okay, so our standard electrode potential for this is going to be 1.56, and be careful, you don't have to multiply by a certain coefficient.